Welcome to all, and in this class we will discuss about coordinate systems. Three types of coordinate systems: rectangular, cylindrical and spherical, in the subject electromagnetic fields. So these are the reference books. And what are the three coordinate systems? The coordinate system is used to represent any object, and there are three types of coordinate systems. One is Cartesian or rectangular coordinate system, second one is cylindrical coordinate system, and third one is spherical coordinate system. In Cartesian coordinate systems, the coordinates axis are the x-axis, y-axis and z-axis, and a point is represented by intersection of three planes, that is x equal to constant, y equal to constant and z equal to constant. So these are the three axes are x, y and z axis. A point is located by its x, y and z coordinates. Say in the x if it is 5 and in the y coordinate if it is 3 and z is its coordinate is 2, the point is represented as 5, 3, 2. Okay, where 5 is the distance in the x axis, y axis and z axis respectively. Okay, so the point is located at the common intersection of three surfaces, the planes x equal to constant, y equal to constant and z equal to constant. The constants are the coordinate values of the point. Say x equal to 5, y equal to 3 and z equal to 2. So let the point B is located at x, y, z, and let each axis is distance is incremented by a small amount. Say x is incremented by dx, y is incremented by dy and z is incremented by dz, so that the point now moves from P to P dash. Okay, so now the new point P dash is given by x plus dx, y plus dy, z plus dz. This is the coordinates of the new point P dash. Okay, so these six planes now represent a rectangular parallelepiped. So look at this diagram. So this represents the rectangular parallelepiped, and the volume of the parallelepiped is dv equal to dx, dy, dz. So here it is represented. The volume of the parallelepiped is dx, dy, dz, and the three surfaces are dx, dy, dy, dz and dz, dx. These are the three surfaces, and the distance dl from the point P, whose coordinates are x, y, z, to P dash, whose coordinates are x plus dx, y plus dy and z plus dz, is given by dl equal to root of dx the whole square plus dy square plus dz square. So this is the distance from the point P to P dash. Okay. Now let us go to this is about the rectangular coordinate system or Cartesian coordinate system. Then we will discuss about the cylindrical coordinate system. In the cylindrical coordinate system, any point is P is considered as the intersection of three surfaces. Here what are the three surfaces? A cylinder with radius rho equal to constant. So this is a cylinder with radius rho equal to constant. A cutting plane. So this is the cutting plane with angle phi equal to constant. So this cutting plane cuts the cylinder with angle phi equal to constant, and another a plane in the z axis that is z equal to constant. A plane z equal to constant. So there are three surfaces with a cylinder with radius rho, and a cutting plane with angle phi equal to constant, and another plane with z equal to constant. So this is about the cylindrical coordinate systems. So any point P is represented by the coordinates rho, phi, z. Okay, whereas in the rectangular, how we call it in the rectangular coordinate system, the coordinates are x, y, z. Here the point P is represented by rho, phi, z. So rho is the radius of the cylinder, phi is the angle made by the cutting plane, and z is the height, or you can say it as z height in the z plane. Okay, so this is about the cylindrical coordinate systems. Here again each of the coordinates is incremented. Say rho is incremented to rho plus d rho, phi is incremented to phi plus d phi, and z is incremented to z plus dz. Remember, when the angle is incremented, that is phi plus d phi, the variation in the radius is given by rho d phi. Okay, rho d phi. Okay. So in the cylinder, as we have said, a point is considered as the intersection of three surfaces. A cylinder rho equal to constant, a plane phi equal to constant, and another plane z equal to constant. So this may be regarded as the height. Okay. The three unit vectors are a rho, a phi and a z. So again we have incremented by small values. The surfaces are rho, d rho, the surfaces. Here the three surfaces. So there we have three surfaces, dx, dy, dy, dz and dz, dx in the rectangular. Similarly here also we have three surfaces. and one of the surfaces is rho d rho d phi, d rho dz, and rho d phi dz, and the volume becomes d rho d phi dz. So d rho is the incremental in radius, rho d phi is the incremental in angle phi, and rho and dz is the incremental in the z plane. Okay, so here we have the three areas and the volume. So how do we conversion? So here the conversion between rectangular and cylindrical coordinate system. How do we convert? So there may arise situations where we need to convert from one coordinate system to another coordinate system. So how to convert from rectangular to cylindrical and from cylindrical to convert? So look at the figure. So here this is the cutting plane phi equal to constant. So here top z equal to constant, and the radius is rho equal to constants. Okay, so now you project here, project in the xy plane, projecting this in the, consider this xy plane alone, you here x equal to rho cos phi. So here cos phi, the angle cos phi may be defined, cos phi may be based by hypotenuse, so the base is x and this hypotenuse is rho. So cos phi equal to x by rho, or x equal to rho cos phi. Similarly, y equal to rho sin phi, that means here sin phi, the angle sin phi equal to opposite side by hypotenuse. So here opposite side, side by hypotenuse, that means opposite side is y. Here the opposite side is y, and once again the diagonal is rho. So y equal to rho sin phi and z equal to z. Okay, so this is how conversion takes place from the cylindrical to rectangular. This is from cylindrical to rectangular. When we convert in the other way, rho equal to root of x square plus y square. Okay, so here it is rho, so it is a diagonal, so root of x square plus y square, and phi equal to tan inverse of y by x, so opposite side by base, so phi equal to tan inverse of y by x, and z equal to z. So these three formula we have to remember while conversion from one coordinate rectangular to cylindrical. X equal to rho cos phi, y equal to rho sin phi, z equal to z, rho equal to root of x square plus y square, phi equal to tan inverse of y by x, and z equal to z. So this is how we have to convert between rectangular and cylindrical coordinate system. Now you consider dot product of unit vectors in, as we have seen, the unit vectors in the cylindrical coordinate system are a rho, a phi, and a z. Similarly, the unit vectors in rectangular coordinate systems are ax, ay, and az. So what is the dot product between them? Ax, ay, az. Here we have written a rho, a phi, az. So these are the unit vectors in cylindrical coordinates. These are the unit vectors in rectangular coordinates. So ax dot a rho. So you can arrive at looking at the figure. So ax, so this is the x-axis, and a rho. So here this diagram we have drawn the unit vectors also. This is az, a phi, a rho. Similarly, we have ax in this direction, ay, az. Okay. So if you draw this unit vectors alone and you calculate the formula, so we will be arriving at ax dot a rho equal to cos phi, ax dot a phi equal to minus sin phi, and ax dot a z equal to 0, since these two are mutually perpendicular to each other. The angle between ax and a z is 90 degree. So cos 90 is 0. Okay. Similarly, ay dot a rho is sin phi, and ay dot a phi equal to cos phi, and ay dot a z equal to 0. Okay. Similarly, when you consider az dot a rho, since az and a rho are mutually perpendicular, and az and a phi are also mutually perpendicular, so cos 90 is 0, 0, and az dot az, the angle is 0, so cos 0 is 1. So here we have 1. So this is the dot product of unit vectors in cylindrical and coordinate system. So this will be also helpful when you convert vectors from one coordinate to another coordinate. Okay, so let us see one simple problem. So here the point C is in a cylindrical coordinates represented by rho, phi, and z, and another point D in rectangular coordinate system given by x, y, z. So specify the distance from C to D. Okay, so first you convert into into rectangular form. Okay, so C of rho, phi, z may be converted into x, y, z. Okay, so in terms of x, y, z, what is the formula we have to apply to convert from cylindrical to rectangular? From cylindrical to rectangular, we have to convert x equal to rho cos phi, y equal to rho sin phi, and z equal to az. Okay, so convert this, and we will be arriving at this point C of x, y, z. Similarly, for the next case, you convert x, y, z coordinates to cylindrical coordinates. Okay, so now you apply this formula. That means rho equal to root of x square plus y square, phi equal to tan inverse of y by x, and z equal to z. And we are arriving at this point D. Okay, rho equal to so much. What is the distance from C to D? So as usual, you can calculate the point C is here and the point D in xyz. So calculate the distance based on the rectangular coordinates alone. Okay, so we are arriving at 8.36. Okay, so this is a sample problem. Next we will go for spherical coordinate system. In the case of spherical coordinate system, here a point is considered as intersection of three surfaces. Here the three surfaces are, one is sphere with radius r, another one is the cutting plane phi equal to constant, another one surface is a right circular cone which cuts the sphere. This is a right circular cone which cuts the sphere with the angle theta equal to constant. Okay, so here there are three surfaces which are, one is sphere with radius r, another one is a cone, right circular cone with angle theta equal to constant, and another one is a cutting plane with phi equal to constant. So this is the case of spherical coordinate system. Okay, so this diagram shows unit vector. So here we have unit vectors as AR, A theta and A phi, and here AX, AY, AZ. Okay, so this is the incremental volume. So now again the radius is incremented by dr and the angle is incremented by r d theta. If we increment d theta, then the variation in length will be r d theta. Similarly, if we vary phi with d phi, the variation in length will be r sin theta d phi. Okay, so the incremental surfaces, you product of this will be r dr d theta, r square d theta sin theta d phi, and r sin theta dr d phi. Okay, these will be the incremental surfaces, and incremental volume will be the product of these three. That means r square sin theta dr d theta d phi. Okay, this will be the incremental volume. Okay, so any point is represented by p of r theta phi. The point is considered as intersection of three surfaces, r equal to constant, theta equal to constant, phi equal to constant. R equal to constant is a sphere, theta equal to constant is a cone, and the two surfaces, cone and sphere, are everywhere. Okay, perpendicular along the intersection. So these two surfaces are everywhere perpendicular along the intersection, and which is at what point the cone cuts the sphere. It gives a circle of radius r sin theta. So imagine this as a latitude. So imagine this as latitude which is runs over the globe. Okay. Similarly, the angle phi is the same as that of angle cylindrical coordinates. So in the cylindrical coordinates, we studied about the angle phi, cutting plane phi. So here also the same thing. Here this angle phi may be considered as longitude. Longitude means which runs from north pole to south pole. Latitude means it runs from east to west. Okay. So remember, this phi is as longitude and this theta as latitude. So now how do you convert between spherical and rectangular coordinate systems? So when you convert from spherical to rectangular coordinate system, x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. So remember, this r sin theta, how this is come means the intersection of the right circular cone with the sphere. The intersection of the right circular cone with the sphere will be having a length of r sin theta. So only we are writing it as r sin theta cos phi, and y equal to r sin theta sin phi. If you project this into xy plane, z equal to r cos theta. So transformation in the reverse direction is achieved. The reverse direction, r equal to root of x square plus y square plus z square, theta equal to cos inverse of z by root of x square plus y square plus z square, and phi equal to tan inverse of y by x. Remember, the angle theta, it's a right circular cone. The theta lies between 1d0 to 180 degree, whereas the angle phi varies between 0 to 360 degree. Okay, phi varies between 0 to 260 degree. Similarly, the dot products of unit vectors in spherical and Cartesian coordinate systems. So remember, AR, A theta, A phi, coordinates of spherical coordinate systems. AX, AY, AZ, coordinates of rectangular coordinate systems. When you take dot product, AX dot AR equal to sin theta cos phi, AX dot A theta equal to cos theta cos phi, AX dot A phi equal to minus sin phi, AY dot AR equal to sin theta sin phi, AY dot A theta equal to cos theta sin phi, and AY dot A phi equal to cos phi. AZ dot AR equal to cos theta, AZ dot A theta equal to minus sin theta, and since AZ and A phi are mutually perpendicular to each other. So the cos 90 which is 0. Okay. So this is the dot product of unit vectors. Let us see one simple problem. Given two, here again two problems